So I wanted to make this video just to kind of give you a one spot for all of these different angles that I've been trying to show you guys about. Um, there's two different kinds of angles that we're going to be dealing with inside circles. There's what's called a central angle, which I think is pretty aptly named. You know that I've got an angle here at the center of a circle. And then I've got what's called an inscribed angle. Now I realize these pictures look the same. They're not, because I'm going to change the one on the right, but I wanted to show you how these are different by starting out by having my pictures look exactly the same. So a central angle in a circle. I lost my dots there. A central angle in a circle is an angle that is at the center of the circle. Okay. So anytime you see these, I'm going to go back and forth between the word arc and angle here. This curvy part of the circle is called an arc. Whoa, that's gigantic. Let's make that a little bit smaller. The curvy part of the circle is called an arc, A-R-C. And then inside we've got the angle, A-N-G-L-E. Okay. If the angle, right, the angle formed by the two segments there, the two radii in the circle, right, the sides of the piece of pizza there, the angle here at the center of the circle and the arc outside on the circle are equal. They have the same measure. So what that means is if I were to draw in and cut up this circle into all these different pieces, and I add up all of these different angles, and I realize they're not the same size, but if I add up all of these angles, those angles are going to add up to 360 degrees. Now that's something that you probably know just from being in high school. A circle is 360 degrees. What that means is that all of these wedges added together, if I add up all these angles all the way around the inside of the circle, they're going to add up to 360 degrees every single time, every single circle. Okay, so what we're going to do is basically I'm going to ask you to find different angle measurements or different arc measurements given one or the other. So on these problems that I've got for you, I'm going to chop up the circle and ask you to find a piece of it. Okay, the inscribed angles are a little bit different though, because let me see if I can do this right here. This is not an inscribed angle. Now I want you to pay attention to this angle measurement here. The angle's not going to move, but I'm going to move the circle. An inscribed angle, I want to basically pull this little red dot back here to the other side of the circle. I can't move the dot, but I can move the circle, so it'll kind of have the same effect. Now, what I want you guys to try and watch here is how does this angle measurement, how does the size of this angle change if I move that back to the center of the circle, right? So how does this measurement here, this little guy, compare to, dang it, come on, that? Did you see what happened to that red line? Right, when my angle's at the center, I kind of outline the angle there. But then when I pull the circle out, what happens to the angle? Okay, the angle gets smaller. So here, I'm saying that the angle at the center and this arc are exactly the same, but when I pull that angle back, it's not the same anymore. The relationship here between your arc and your angle, the arc measurement is twice as big. So the angle is half, however you want to think of it. So I'm going to put some actual numbers in here to kind of help you see what's going on. So if here my arc is 80 degrees, my central angle is 80 degrees. Here, if my arc is 80 degrees, my angle back here is half of that, 40 degrees. Now, this is the only one where you've got two different things that I could ask you when you're going to have to go back and forth between the two of them. The inscribed angle, the one back on the circle, is half as big as the arc. Okay, so I've got some questions here. The ones on the left are central angle questions. The one on the right are inscribed angle questions. Let me grab my highlighter here. So what I'm asking you here, I want you to find the measure of arc. See the arc across the top? Arc EGD. So we're going to go from E. We're going to walk around the outside of the circle through G, back to D. So I need to add up all of the little pieces that make up that big arc. So I've got a little bit of work to do because I only gave you a couple of angles here. So for starters, from G to D, here to here, I know that that's 180 degrees without having to do any math because that is half of the circle. Okay? So what I need to add to that, to the 180 degrees, is from E to G. I need to figure out that piece. Okay? Well, I know this chunk is 58. So let's see if I can't find just this little wedge right there. So I've got 180 degrees from D to G around the outside. If I subtract off 82 and 58, I know that this angle out here, this arc out here is 40 degrees. So to find the highlighted piece, EGD, I'm going to add up 180 and 40 and 58. So this arc is 278 degrees. This is exactly what I've got set up as an assignment for you today. I'm giving you a picture and I'm asking you to either find an arc or an angle measurement, and you're going to have to use, for these central angle problems, you're probably going to have to piece together smaller ones to get the answer. The inscribed ones are a little more straightforward. So I'm wanting here the measure of this arc on the outside. So I'm going to take this angle and I'm going to double it. So this guy's 64. Okay, that's it. Okay, same idea. The one on the left is central angle. The one on the right is inscribed angle. So I'm looking for angle this time. Angle, right? See the notation switched? ILG. So ILG. I'm looking for this angle here. Okay, so I need to piece together the outside pieces here. So I know that this arc is 54 degrees. I need to find this arc here, and then I just add it to 54 and I'm done. Well, let's see. I've got a semicircle here. So J all the way around to G is 180 degrees. That means that this is 119 here, which means same thing, K to H is a semicircle. So this has to be 61. Oh, I could have just used vertical angles. 61, 61. Because that X in the center of the circle. So I'm going to add together 54 and 61. What's that, 115? All right, I'm looking for angle E back here. So I'm going to take 126 coming in. I'm going to divide by 2. So this is 63 on the inside. Okay. IMK. It looks like most of these central angle ones throw in that semicircle is 180 degrees. So just be aware of that. This one I think is going to be a little bit easier if you kind of look at what we need versus what we have, right? I need IMK, so this big arc around the outside. Well, I know the two pieces that aren't highlighted. So I'm just going to take 360, the whole circle, and I'm going to subtract off, what's that, 115? Right? 40 plus 75 is 115. So I'm looking at 245 degrees. Right? VWX, arc VWX. So V around to W to X. Okay, now this one had a couple of extra lines thrown in there. What I'm looking for, I'm going to follow the sides of my angle out. Right, here's my angle. If I follow the sides of it out, double your angle to get the arc. This arc is 202 degrees. All right, I got one more. Angle UVS this time. UVS. Oh, that one's the easiest one we've had so far. So I need to add together these two pieces that make up the inside of that angle. So 37 and 45. I got 82 degrees. And then here I've got an inscribed angle. Follow it out to get the arc. So times 2, 76. Your assignment, I'm going to do the same thing. It's half and half. Half of them are central angles, half of them are inscribed angles. And I'll put them in sections together. Like all the central angles will be together so you can focus just on that. And then all the inscribed angles will be together so you can focus just on that.